Hello, Mr. Mailer here, your online math teacher, and welcome to my channel. Today we're going to be continuing my video series on trigonometry, and in particular looking at proving trigonometric identities. So if you find this video helpful, consider subscribing and hitting that like button, and let's go. Now, if you haven't gone and watched my videos on how to simplify trig identities first, I strongly encourage you to go look at them before you watch this video. That's because simplifying is easier than proving. It's kind of like you want to learn how to walk before you learn how to run. It's the same idea with math. You want to learn how to simplify your trig identities before you learn how to prove them. So make sure you're strong enough at simplifying first. But if we want to go about proving them, and you are ready, I keep my first three tips from before. Look for a place to use reciprocal, quotient, or Pythagorean identities, and in the more complicated scenarios, you'll use addition, subtraction, double angle formulas, other identities as well. This is just a basic introduction. You'll want to utilize algebra skills in combining fractions, factoring, multiplying by 1 in a fancy way, as I put it at times. And when in doubt, write things in terms of sine and cosine. So all those tips apply still, but now I've added two more that weren't there with our just simplifying videos. You want to make sure you do not work over the equal sign. Pick a side and stick to it, and I'll explain why in a minute. And additionally, when you're picking your side to start with, pick the complicated side, because it's going to give you more to work with if it's more complicated to begin with. And we're going to usually think of as addition as being more complicated than multiplication. So an example where we see that is like number 1 here. If I need to decide which side to start with, and I say both don't look too bad, they both look relatively similar, we're going to typically want to start with the left-hand side because that addition is more complicated than the multiplication you see on the right. Now, the reason we can't work across the equal sign, because I know that's the most tempting thing for every single high school pre-calculus student to do, is because if you were working over the equal sign, that would be working with the assumption that both statements were true, that these are in fact equal. You cannot assume that. The whole point of this problem is to prove that they are the same. So you can't use the fact that they're the same in your proof, which is inadvertently what you'd be doing when working across the equal sign. So just don't do that. So we're going to start with our left-hand side here, because I said this is more complicated. It's where the addition or subtraction is, and I like to abbreviate LHS or RHS to denote which side am I starting with. So this is a reminder for myself. Now, typically when you want to begin these problems, you look to see, is there any algebra I can do? Is there a Pythagorean identity that's obvious to apply? Well, sometimes there is, sometimes there isn't, but a tried and true thing that always helps: write everything in terms of sines and cosines. I know it's going to create fractions here, and I can always combine fractions once I do that. Now, I added a 1 underneath that cosine just to emphasize that I'm now going to think about these as two fractions. And here's where I like my algebra. I can combine fractions whenever I want by getting a common denominator. So the easiest common denominator to get here is just going to be sine squared of theta. So you can see I multiply by 1 in a fancy way. So sine squared theta over sine squared theta. That's why I multiply my cosine squared theta divided by 1 by, to be able to combine it in one fraction. Now, here's where we get some traction. I can recognize now that I've combined this, I have a cosine squared in each of my terms in the numerator. So I'm going to say, hey, I see that, and it tells me, can I factor that out? So that's exactly what I'm going to do now. I'm going to factor out a cosine squared from both those terms. Once I've done this, I recognize I now have a cosine squared divided by a sine squared. Well, that's a cotangent squared. So I'm going to replace this with a cotangent squared. And then I'm almost at what I want. I just need this 1 minus sine squared theta to become cosine squared theta. And I can do that because it's our favorite Pythagorean identity rearranged. If I rearrange sine squared theta plus cosine squared theta is equal to 1, I will end up with 1 minus sine squared theta is equal to cosine squared theta. And just to get into a good habit, since I want this to be cosine squared theta times cotangent squared theta, I'm just going to change the order of this multiplication, because remember, multiplication is commutative. So we get cosine squared theta times cotangent squared theta, which is exactly what we want. This is that right hand side, so I'm writing RHS. And then I put myself a little check mark to emphasize I started with this left-hand side, and I only manipulated the left until I got to equal exactly what the right-hand side is. So this is my first example. The next example I have is when you have two different sides that look equally complicated. Now, even though they look equally complicated, there might be an easier one to pick, but guess what? These are identities, so from a technical standpoint, there's going to be a way you could work from one side to get to the other regardless of the side you pick. So in this case, you probably aren't sure which side to start with, so let's just say we start with the left-hand side first and see what happens. Because this is a common thing when you prove identities. Maybe you're going to start with one side thinking it's appropriate when you're not sure, and kind of get stuck. So here's an example where I personally would get stuck here. So let's start with this left-hand side, our 1 minus cosine of u over sine of u. And the first thing I might be inclined to do is break up my fraction. I don't really see anything else to do, so I can do that. And then that gives me a cosecant of u minus a cotangent of u by my reciprocal and my quotient identities. But once I'm here, I don't really see anywhere else to go. I want to get it to be the right side, but I don't have a clear next step. If you ever get to a point where you don't have a clear next step, that's fine. You will make mistakes, or you won't necessarily make mistakes along the way, but you won't always make the best choices to make your life easy. And you can always backtrack a step or two. Maybe I get here and decide the left-hand side was maybe not the side I wanted to start. So I say, well, what happens if I start on the right-hand side of my equation? So I start with this sine of u divided by 1 plus cosine of u. Maybe I want to know what can I do next here. Well, the first thing I can think of is, well, maybe I want to try to change the denominator a little. And the best way for me to possibly change that is going to be to multiply the numerator and denominator by 1 minus cosine of u here. This is kind of the same thought as when you were conjugating stuff in the past. This is my motivation, except when I do my 1 minus cosine of u, it's because it will introduce a Pythagorean identity in the denominator. So this is just a little trick here that I happen to know from building up good intuition over time. You'll eventually build these same intuitions. And when you do that, you have sine of u times 1 minus cosine of u, all divided by 1 minus cosine squared of u. So this is where I've ended up here. Already something that looks a little bit more promising than before. So now I can do exactly what I mentioned. This looks like a Pythagorean identity in the denominator, which it is. I can replace 1 minus cosine squared of u by a sine squared of u. And I'm going to leave my sine of u in the numerator and my 1 minus cosine of u that it's multiplied by up there. From here, you can see the sine in the numerator will cancel with one of the signs in the denominator to leave you with a 1 minus cosine of u divided by sine of u, which is exactly that left-hand side of the equation. So we are done here. So this is an example that can show you can start with one side, work a little bit, and maybe not get anything that's obvious what to do next. That's fine. It's going to happen as you're getting better at these. Just start over, maybe trying working with the other side, or maybe try something else different with that side you started with if there was something else obvious that you could try. So I hope you find this video helpful. If you did, hit the like button, and good luck proving trig identities. But remember, you will not get great at these overnight. It takes time.